We're going live. Hello, okay. Good afternoon, everyone, and welcome to the virtual Agile Shift. Before we start, I want to inform you about a feature in this presentation that'll help this session be a little more interactive. Let me direct your attention to the question mark icon in the upper right of the presentation screen. If you click that icon, it will open the question and answer chat. From there, you'll be able to see, send me any questions you have, and Todd will answer any that we have time for at the end of this session. Just a reminder, you can enter your questions at any time. So with that said, let me introduce today's presenter. Todd Little is the chairman of Kanban University, and today he's going to share the foundations of business agility feedback loops with us. Todd?
Hello there. Sorry for the delays. I guess this is an example of shift happening. My name's Todd Little. I'm chairman of Kanban University, and I'm going to be talking about feedback loops, the foundation of business agility. Something I find particularly important, as we encounter more and more risk and challenges. We need resiliency, and we certainly have discovered it here. We need multiple approaches. We need feedback loops, but let us know that things are working. So I'm going to talk about feedback loops a bit. Just a little bit about me, chairman of Kanban University. My background is a chemical and petroleum engineer. The reason I include that information about my background is because that's where I really got my foundational training in how do I operate. And although I was developing software and managing and leading teams and organizations that were developing software, my formal training background was in chemical and petroleum engineering. And feedback loops are a fundamental element of what we do in the engineering world. And because of that, when I got into the software and I started seeing people talking about how, back in the 90s, need more process, need more structure, we're too lackadaisical or haphazard in our approaches, it just wasn't quite resonating with me because I knew that the way we were, connected really had to do with learning and developing as we went along. So through my history, I've ended up learning a lot about that. That's where I got connected into the Agile community back in the late 90s. Ran into Jim Highsmith and Kent Beck and Alistair Coburn, and really started to like what they were talking about because it really matched my philosophy in general. So my career with Landmark, Halliburton, I was VP of Product Development and Delivery at IHS, and now I'm with Kanban University. Along the way, I was also involved with the Agile Alliance on the board of directors of the Agile Alliance for 7 years, and also a founding member and past president of the Agile Leadership Network, where we really try to focus on how we think differently from a leadership direction. Also a book author, Stand Back and Deliver, Accelerating Business Agility. So as I talk about my background in chemical engineering, as I was reading the Scrum book, the original Scrum book by Ken Schwaber and the late Mike Beadle, it really, I got a little chuckle out of a story in there that Ken relates of how he learned. He was trying to sell software methodologies to Dow Chemical, I think. Was it Dow? No, maybe it was DuPont. DuPont, I think it was. They started laughing at him because she was trying to bring in a heavyweight methodology. They said that can't possibly work. And we've discovered that. We've known that in the chemical engineering world for a long time, that you just can't, anytime you have any degree of variability, anytime you have any degree of uncertainty, you've got to have feedback loops in your system. You can't predict things up front. And that's what we've learned in the chemical engineering industry, and the joke going around in the chemical world as process control got to be able to handle such complex systems is that in the future, chemical plants or processing plants would all be run by a man and his dog. And the point of the man was to feed the dog, and the point of the dog was to bite the hand of the man in case he tried to change any of the settings. Now, this is sort of it's just a fun joke, but that's the point, is that you can get some fairly good control. Controlling your systems is actually a good thing. Sometimes I feel like when we talk about agility, agilists go, oh, we don't want control. Well, of course, we want to control in the large scale. We want to get to the right answer in the end. But what we want is we want empowerment and other things along the way. So if we look at types of control systems, we really can break them out into two different categories. Open loop control systems and closed loop control systems. Now what happens in an open loop control system is we don't really have any feedback. What we do is we really focus on understanding the inputs and the process. And by understanding the input and the process really well, we can get predictable results. And this works as long as the systems are quite stable. In a closed loop system, the same thing. We have inputs, processes, and results, but instead of really focusing upfront on the inputs and the processes, we focus really more on the outputs and the feedback loops back into the process and back into the whole system in order to help give us an ongoing control of the system. So those are the two basic systems. Let me give you some more specific examples here. So as we look at open loop control, we've got this flow, some output response, controller, process, and output. So we look at something simple like a toaster. Now the toasters can get as complicated or as simple. I'm going to go with a very simple old-fashioned toaster that really works mostly off a timer. Okay, so I set a timer, and based on that timer, the toaster is going to turn itself on, run for a period of time, and whatever comes out is my toast. And for the most part, that works quite well. If you have a well-defined system, controlled system, you can operate it that way. So that's an open loop. You get your results, you get your toast, you're happy. Let's look at a closed loop system. So in a closed loop system, the key element here is this assessment. An assessment is, what do I want to change? Where am I? How am I deviating from a desired state? And then based on that, we make some corrective action that feeds through to the process. The process does its work. You get some actual output, which happens, but then you have a sensor, and that sensor provides the feedback loop that tells us, are we on target, or have we continued to deviate, or do we need to take additional corrective action? So let's take a look at an example here of a thermostat and something particularly important to Houston, an air conditioner. Okay, so we have an air conditioner set, a thermostat set, a temperature. We have this feedback signal that's come in. Do we need to turn on or off the air conditioner? If we're too hot, we turn it on. If it's too cold, we let it go. The air conditioner turns on, it cools the air down. Eventually the temperature drops, and when the temperature drops, the signal says, oh, we no longer need the air conditioner on, let's turn it off. And that cycle continues and continues. And there's a very nice closed loop system that gives us feedback and does the important thing, which just gives us the output range that we want. Another simple example that I really like is a shower. In past life, I traveled quite a bit. Haven't been traveling at least since March, so which is actually maybe one of the good things about this situation. But when I travel, you go into different places and you'd have different types of showers, and so you have to learn, how does this shower work? Well, we take a look at this. Well, what do? We turn it on, we pull it to a certain place, and we test it. And we test it by checking the output and looking at the temperature. And the sensing device is my hand. So my hand checks and says, well, is this the temperature I want? And if not, then I make some adjustments. Now we'll talk about this a little bit later because it actually takes some time. There's a delay. I'll get to that piece a bit later. But the whole point is that this works really well. And it's a differentiation from the prior example where I had a machine doing the sensing and the corrective action. In this case, there's a human being involved, which is why I like this example particularly, is that it shows that there's a little difference here, a fairly important difference. And that fairly important difference is that I don't actually need to know the exact temperature. All I need to know is how am I deviating from the desired state. So I have to be really good at assessment. I don't have to be nearly as good at measurement. And that's something I'll come to, possibly come to a bit later. Now, the other thing is that there's multiple variables here at play. One is the temperature and the other is the flow rate. Okay, so these are the two things that we're combining. So these are both things I need to control, which in this case here of a single valve maybe just is two separate and relatively orthogonal approaches to controls. But if I have more of an old-fashioned valve system, then each one of these valves impacts the other. I have to find the perfect combination that gives me both temperature and flow rate by adjusting both valves. And usually this is a fairly common behavior we have as you get more complicated systems. You don't just have one valve, one control to work with. You have multiple controls and multiple variables. And we'll get into that more as I go through this. And I just said, delay is an important thing. You make the change to the control system. It may take a while before you sense the result and the change in the result. So you have to be cognizant of that delay and realize that in many cases you have knobs to control in your feedback loops, but there's going to be delays. And as you have those delays, you have to be cognizant of that. In many cases, we found certainly people are quite familiar with the Satir change model, showing that actually you make a change in a system, more organic systems, or in her case, she was working with mostly alcoholics and drug dependencies, and found that when they made the change to the system, frequently things got worse, and then over time they would get better, and there would be a delay in that process. So this is a thing you have to watch out for in systems. Some systems have delays, and some systems actually operate inversely to the desired intent initially, and that's what we have to watch out for in our business systems, because they're quite complicated and these behaviors happen. One framework I like for looking at feedback loops is the Cynefin framework by Dave Snowden. And in this we have different domains. We have the obvious domain, complicated domain, complex domain, chaotic domain, and in the middle we have something called disorder. I'm going to focus on the first three, obvious, complicated, and complex, and how they differ from a feedback perspective. So in the case of the obvious situation, we have inputs, we have a system, and we have outputs. And the range of the distribution is quite narrow. In these situations, the cause and effect is obvious to all. It's the home of the known knowns. We know it, we can understand it, it's simple, it's repeatable. And for these types of systems, an open loop system, an open loop control model works. We can focus on inputs and processes, and we can get outputs. Works really well, no problem. In the complicated domain, the problem is it's not quite as obvious what's going on. We have inputs, we have what looks like sort of a black box on first analysis, output, and then this distribution is a bit broader as well. Still moderately narrow, but broader. The problem here is that it's not obvious, which means cause and effect requires some analysis. So we have to do that. And when we do, by doing the analysis, it becomes aware. So this is where we bring in experts to analyze the system, and they understand it, and they can explain it to others, and then it becomes not still obvious, but at least it's understandable, and we can manage it accordingly. So we do the analysis. This is largely the home of the known unknowns. If we move to the more of what we have of a complex situation, here we have inputs, we have a process. Again, it looks like a black box, and then we have outputs coming out. And the distribution is much more, is broader, and also tends to have these long tails. It's much more difficult to control it. Our challenge here is that we can't really understand the system by doing a detailed analysis of it. These types of systems can only be perceived in retrospect. So how do we do it? We do this by, the retrospect is we send probes through the system. So we send a probe through the system from input to output, and then we have the feedback loop that helps us understand the system. So our control of the system is happening by probe and responding. It's the home of the unknown unknowns, the things we don't know about, the things we can't really know about through detailed analysis, and frequently some of the biggest types of challenges we have in knowledge work in general. So the complex domain is certainly an important one and something that we see a lot, and some of our biggest challenges. Now, if we could bring this context back into the shower control system, one would look at this and say, this is actually seems like it should be pretty obvious, should be pretty simple. And in fact, it is pretty simple. However, I still use a feedback loop. in order to make my assessment, right? And so it works. The feedback, the point I try to bring here is that feedback loops can be valuable in almost any situation. And it's the appropriateness of the feedback loop that you're trying to figure out. What's the level that you need in order to really understand the system? And so that's why I bring that and come back to it. So we see feedback loops all over the place. They've been around, people have been using them for a long time, different areas. We see it in the Plan, Do, Study, Act, often called the Deming cycle or the Shewart cycle. We see it in the Build, Measure, Learn of the Lean Startup. In this case, focused more on product than on process improvement. So product improvement versus process improvement. We see it in John Boyd's OODA loop, the Observe-Orient-Decide and Act. John Boyd was a fighter pilot, and this was a means by which to train how fighter pilots will operate. I present the standard system perspective of a control loop. We also have the causal loop diagrams that Peter Senge made famous, where it's a balancing loop. You've got some desired value. That's what you're targeting. There's a discrepancy, your assessment. You make an adjustment to it. You get the actual value, and you continue the circle. So these are all different examples of feedback loops. Also see examples in quite a lot of them in biological systems, in organic systems. Certainly one that familiar to me. My son was recently diagnosed as diabetic, and so we have the sugar insulin, the glucose insulin glucogen feedback loop. How the body controls and keeps the blood sugar to be a relatively constant or in balance. So control over the blood sugar level, which in my son's case, since he has not been producing the insulin or not as much insulin, that's something we have to help the body do. We have good examples in the software world. One of the things they're trying to do in feedback loops is identify what the feedback loop is, but also do things that shorten the cycle as much as possible. So we have the TDD cycle, test-driven development cycle, that's trying to work on a regular basis of making sure we're building quality into software. We have DevOps cycles. How quickly can we get releases in the hands of customers? And so the things that, if this is a case of frequently we have with what brought around DevOps is that there are big delays from the time we develop something from the time it got into the hands of customers. Well, what can we do with DevOps? Can we shorten that cycle? Can we streamline that? And by streamlining it, getting faster and better feedback. So all good examples there. And really, a lot of it all comes back to the granddaddy of them all, the scientific method. It's been around, it's been tried and true. We're trying to understand what's our hypothesis, observing it, testing data and collecting it, analyzing results, and then feeding back and continuing to iterate. So as we say, the scientific method just keeps going around in circles. These all look the same. It's just a circle. Feedback loops are got to be really simple. I use this example from the John Boyd OODA loop because this is the simple version, but you actually look at it in greater detail, there's a lot more to it. There's feedback loops all over the place. There's multiple feedback loops. And if you really want to look at where do you have your feedback loops in your system, and also look to see where should there be feedback, where are feedback loops broken? Because anytime you have a broken feedback loop, that's an opportunity for misinformation. And opportunity for misinformation, I find, is also an opportunity for frequently organizational politics. Because if we don't have transparency and we don't have really clean feedback loops, we have those clean feedback loops and clean data coming in, clean analysis, then we can have a very good control system. Alternatively, when we have broken feedback loops, it opens the opportunity for many types of challenges. So not really going to go through this in detail, but just to show it that systems can be very complicated. This is to lead into, from a control system perspective, what we're looking at is the fact that we also have multiple variables. I showed this a little bit with the shower situation, but if we look at it in a general context, we've got some output responses, multiple responses that we're looking for because we're looking at multiple output variables. And these are all feeding through it, and we have multiple approaches to controlling it. We have lots of different knobs. Some knobs might be controlling multiple variables. They may not be independent variables. Usually not. Usually they're quite dependent. We control one thing and it can change something else. So what we're trying to understand is what's the right balance? What balance are we looking for in our overall control of these systems? Because we won't be able to get perfect control over all the output variables. There's going to have to be preferences and a general assessment of where we at collectively. So if we look at it in the case of perhaps software, your output variables might be things like value, schedule, cost, and quality. And your controller, your knobs that you have, what could you do? Well, you could adjust your scope, you could adjust your dates, you could change your team, add people to the team, or adjust it, bring experts on. You can adjust quality, and you can adjust your process. These are some of the various knobs that you might be able to work with in order to get a control system that operates in a continuous fashion. Now, the one thing that I've seen in my career that is a challenge is when one output variable takes dominance over the others. And the one that I see in our industry, and many industries, is that schedule rules. Schedule becomes the most important thing. And sometimes it becomes the only thing. What happens, and that's fine, that gives you a closed loop control around schedule, but potentially at the cost of breaking the loops that are associated with the other variables. So give a little story about this. This is the Ford Taurus. Nothing super special about this car. It's back in the mid-1980s, but it was a fit-for-purpose car at the time. It was exactly what Ford needed. Ford had been about to go bankrupt, close to going bankrupt. Chrysler had just gone through bankruptcy, and the Ford Taurus saved Ford from going bankrupt pretty much. It was a huge success when it first came out. Great, it just met what customers needed at the time. The problem here, and in order to do that, the project manager made sure to do extensive feedback loops, get feedback from customers, get feedback, do early prototyping, and designs, and really tried to make sure that he was nailing it in trying to get what the customers needed. And they hit it, and they really did. They saved the company, fantastic. The challenge here is that the project was 6 months late. So the project manager probably saved the company, but he was 6 months late. What do you think happened? Promoted? No. Because that's what matters. If you're a project manager, you make sure things come out on time. That was the mental model that they had at the time. So, lesson learned. What do you think happened with the second revision of the Ford Taurus? What did the new project manager make sure of? They were on time. Cut corners all over the place. Who needs those extra feedback loops? Who needs this customer feedback? Who needs to get all that information? I know what we want. Let's just go do it. And that's what they did. A huge disappointment. Not a disaster, but just nowhere near as successful as the initial release. But it was on time. So they broke all these feedback loops in order to make sure that they met one, which turned out not to be the one that customers probably cared about. I've seen this myself. When I was working the company, we were great. This is in the mid-90s. Our customers just loved us. We had customer satisfaction numbers in the 90s, product satisfaction in the 90s. We had gained a market share significantly through this time. So we must have been doing something right, meeting customer expectations. They loved us. The problem was that we weren't making all our schedule estimates. We were delayed, possibly 6 months behind some cases, possibly more sometimes, from what we initially targeted. But our customers seemed to be okay with that. They loved the product, they loved everything. So, but the seemed like an opportunity. We must be able to get better at this. There must be something we can do to deliver better and faster. So we had someone come in and they created what they called a calendar of innovation. So in this calendar of innovation, the idea was every month we were going to tell our customers exactly a product that we were going to deliver. It was going to be innovative. It wasn't going to be the same old thing. It was going to be something with significant innovation in it, and it was going to deliver in that month. And that calendar was printed in advance, and it predicted exactly what we were going to deliver each month. So what was the behavior that created? It created the behavior that, in fact, a product was delivered at the end of each month that had some innovation in it. Not necessarily the product that everyone wanted, but a product. So what do you think our customers thought about this? Unfortunately, their word was crap on time. And that's not the type of endorsement you want from people that love your product. So the lesson learned here is that you've got to be thinking holistically. You can't just take one of these feedback loops and say, I'm going to absolutely focus on that. You got to be looking in terms of what can we do and what's actually going to bring the desired outcome in the value system. This extreme closed loop in one area really creates open loops in other places. These open loops, things which are not being dealt with in the feedback system, and I think that creates a very unhealthy situation. What you want is a very healthy situation where you've got balance. Balance should be in place and should be incorporated all throughout. So you're looking at all of these: value, schedule, cost, quality. What are you optimizing across the board? And that controller is people. The people, the executives, and the team and the executives should be that control system. They're actually analyzing this data on a constant basis and making decisions how they're actually going to respond to customers, to the output needs, which is really customers. Let's look at an example here, another interesting example from the auto industry. This is the Toyota Prius, their first hybrid car. And as they were designing the hybrid car, what they realized is they hadn't done one before, and they didn't know how the transmission and the interface between the transmission and the drive chain was going to all work, because they had never done a hybrid engine before. So what they would normally have done is done a big design up front, because they knew their cars and they would have designed it all out from the beginning and then maybe iterated around on some of the finer details. They chose a different approach. They said, let's just design an interface where these two can come together. And then they set off and had 9 different research teams working on what this would look like, and chose one of the paths by which they would then finally integrate. And all of them had to design to a common interface. And that was their approach. So they had built-in flexibility into their design because they were dealing with something unknown and unknowable at the time. Worked really well. They were able to come up with something, and it fit by having the feedback that enabled that to happen. We see this also in the software world. Those of you familiar with software and object-oriented design, it's we're trying to get loose coupling. The looser we have coupling, the more we can decouple, and we can design for less interdependency. It's a great technique, and it helps you with ability to make future changes down the road. If we have very tight coupling, we end up with frequently what's called the big ball of mud, and the big ball of mud doesn't have a lot of ability to be separated. It's one big ball of mud. Loose coupling gives us much more capability there. If we look at how the auto industry has evolved, now we look at Tesla, and Tesla is incorporating ongoing feedback. They're able to make changes on the fly by making digital changes because so much is driven by software. So this is how they've been able to take it. They get their feedback, they're able to get recording, and then also able to update. So they're able to cut their feedback loops drastically. So I think this is obviously the direction of the system in general. We're going to be seeing more and more automated feedback and built feedback into the systems. So if we look at organizations and business chain, I had spent most of almost all my career in the product development cycle. So I was with product companies, and even when I was not with product companies, it was acting as though it was a product company. And in these cases, we have the pipeline here, we assess what the market looks like, we do a product development, and then we have sales. So this is a standard, sort of a approach for workflow for a product company. And what's important here is that we have feedback loops that tell us, based on our sales, how are we doing in actually meeting the market need. So these direct feedback loops are really important and help really provide guidance in product companies to keep them focused. Now, we can go to the other extreme where we have more of a contract model. And in the contract model, we come up with specifications, we do some development, and then there's delivery. And there may be fences or brick walls that we have to cross over at each one of these stages. And it's varying degrees of how these models are run, but at the extreme, it's a pure open loop system, right? It's just upfront, do it. And now it never is actually fully open loop. There's always some degree of feedback, but there's oftentimes significant barriers put into the feedback. For example, if we do the specifications and we say, oh, that's not what we want, then we've got to go through change control or something else that's designed to really inhibit feedback. So we have sort of a dotted line feedback in this process. And then we have something in the middle, something I've seen with internal IT. They can operate either way, right? Internal IT can either be operating much more in this contract model, or they can be operating in the more like a product company. And I think to the extent they operate more like a product company is the degree to which how well are they feeding through the pipeline, and how well are they getting the feedback loops back in, or are they putting in systems in place that actually inhibit feedback. So this was an eye-opener for me as I moved from dealing a lot with product companies, which were second nature to me, moving towards frequently working with more internal ITs and contracting, which didn't have this real strong concept of feedback. So the importance of really here, the whole point of feedback is that it's a learning model. How do we learn? How do we get the feedback loop that helps us learn something? This example I use, being from Houston, lived through Hurricane Rita back in 2005, and this was a forecast made by a number of different weather services as of a particular point in time, I guess on the 22nd of November, and Hurricane Rita is just off the coast. It's a significant beast. It's a Category 5, which is the highest level, and we had just witnessed Hurricane Katrina doing significant damage to New Orleans, and so we were pretty scared, wondering what's going to happen. So these are all the forecasts that we had from weather services, and what do we know about each one of these forecasts? What we know is that each one is wrong, because it's forecast, it's a guess. Collectively, they tell us something useful. It tells us sort of the band of where we might be concerned, from the Louisiana coast down to possibly Corpus Christi. So that area is something that's definitely of concern, and being in Houston, where we're sort of in the center of the forecast, tells us we better be prepared, better be prepared to do something about it. So it's good information. Now it turns out that they're all wrong. This is approximately the path that it went. It went to the east of Houston, which spared most, was significantly lower damage than anyone really had anticipated. So it got very lucky here. But this is useful, and we do have that crosshair telling us some data, measured data. That's useful. We can use that measured data and update our understanding of the situation. And this is what we do. So we'd go from a forecast with a band to understanding based on measured data, how is that moving around? And eventually we can learn, well, this is where we should be concerned, and approximate times and so on. So this updating of information is the feedback, getting new information, getting new models, and then building it in from there. Now, we don't really have controls over the hurricane. But we can react to it appropriately. At least not yet. We haven't been able to control the hurricane. I like this model of incrementing versus iterating that my friends Jeff Patton and Alistair Coburn have written about. So in this case, we are going to be, we've got Da Vinci is going to be painting the Mona Lisa. So if we're incrementing, got an idea, we could build this up bit by bit. So paint the top, paint the next quadrant, and then finally finish it off, and we have the masterpiece. So this is incrementing. This is having an idea and building up in pieces. But incrementing calls for a fully formed idea. So this only works if we actually know what the end is going to look like in advance. Iterating, in this case, what we're doing is building up a rough version, validating it, and slowly building up quality. So we have an idea for something, a woman in a pastoral setting. We start with some sort of sketch, we build up some additional quality, and eventually get the masterpiece. So the idea here is we're getting feedback, we're getting information, and refining accordingly. So iterating allows you to move from a vague idea to a realization. And this is important when you don't know or can't know everything up front. And the approach is feedback loops are the means by which to enable this. And to me, this is the essence of business agility. How do you get to what you really need, not to what you thought that was needed? The objective is get it right at the end, not to get it right up front. So with that, let me move on to just a bit about how Kanban works with feedback. First we have to start with, what do I mean by Kanban? Well, many people think Kanban is just stickies on a wall or a simple to-do in progress or done, but there's a much more richness to the Kanban method than this. Kanban method teaches organizations how to understand, visualize, and measure systems of work to continually improve and consistently deliver results. A set of proven practices and approaches that scale from individuals and teams to the enterprise. You see the picture down below. It's a much more rich workflow. We have WIP limits. We have an upstream understanding of what is we're trying to do, an inventory of options, and through the downstream. All of this is built around the concept, many concepts of feedback. So in our general practices, we have a specific one for feedback, but I'm going to go through all of them. And feedback is a key part of many of them. Visualize showing work. All about getting feedback from visualizing. Limiting work in progress. It means to cut back on work in order to make sure we're getting flow. We manage flow, and we use predictable data to manage the flow. We make policies explicit in order to make sure everyone understands. And part of that's feedback loop as well. Feedback so we know how everyone's working. Establish feedback loops, a key part of what we do. And improve collaboratively, evolve experimentally, using the scientific method. So again, of using feedback loops. So feedback shows up frequently in the approaches we use with our general practices. What types of feedback are boards? Or boards are feedback. You see something, it's a great form of letting people know what's happening. There's a feedback loop associated with that, and it comes visually. We use metrics to understand where things are going from a feedback loop to make decisions. And then we have meetings and cadences that start at the team level, but scale up through operations review, risk review, and strategy review. All of these things collectively help us with building feedback loops into the system so that we can improve our business agility. So if we look at this visually, start with visualize, see the system, see how it behaves, understand the system. We use an approach called static, the systems thinking approach to implementing Kanban. Understand the system. How does work flow? Or how does your workflow work? We want to understand, where does the work process, how is it put together, and then from that we can build a Kanban, we can design a Kanban system. We can focus on flow, making sure that we've got, how do we get from ideas to the package at the end that customers really care about? How do we balance demand and capacity? Can we shape our demand? Can we improve our capacity? All things to look at. All of this to try to help flow. We limit WIP, limit work in progress. That's again about trying to make sure our flow is predictable, and we work on bottlenecking debottlenecking in order to help the flow across the system. We scale up, dealing with multiple teams, dependencies, or also scaling out to deal with the upstream portion of the system. We take measurements in order to provide feedback to the system, incremental process improvement by understanding the system, and then also feedback from the delivery. How can we improve the service or the product? So this is the whole essence of what we're trying to do in the Kanban method. So here I'm going to leave you with a towards the end here a thought. This back in the 1980s, John Cleese, who was of Monty Python fame, also nearly Headless Nick in the Harry Potter series for the younger crew, and been in a number of movies, was doing at that time back in the 1980s was doing management videos. And one of them that caught my eye at the time was called The Importance of Mistakes. And I think this is the essence. This is the time we really, had already been trained in the chemical engineering with feedback loops, but I think he really hit it really well in the business world of the importance of mistakes and the importance of feedback loops by telling a story about Gordon the Guided Missile, a childhood book that his mother read to him, and it was the one he remembered. He's telling the story about Gordon the Guided Missile. Let me play it for you. Oops, I'm going to put it. Sound is not good. Let me try it again.
Todd, the audience cannot hear.
Okay, let me just read it. Let me stop it. Let me read it. I've got it printed, so I was worried that might not happen. So I will read it. The first nursery story I ever remember my mother reading to me was Gordon the Guided Missile. Let me explain why the guided missile found this special, warm place in my heart. Gordon the Guided Missile sets off in pursuit of its target. It immediately sends out signals to discover if it is on the right course to hit that target. Signals come back. No, you are not on course, so change it up a bit and slightly to the left. And Gordon changes course as instructed, and then rational little fellow that he is, sends out another signal. Am I on course now? Back comes the answer, no, but if you adjust your present course a bit further up and a bit further to the left, you will be. He adjusts his course again and sends out another request for information. Back comes the answer, no, Gordon, you've still got it wrong. Now you must come down a little bit and a foot to the right. And the guided missile goes on, making mistakes, and on, listening to feedback, and on, correcting its behavior until it blows up the nasty enemy thing. And we applaud the missile for its skill. If, however, some critic says, well, it certainly made a lot of mistakes on the way, we reply, yes, but that really didn't matter, did it? It got there in the end. All its mistakes were little ones in the sense that they could be immediately corrected. And as a result of making many hundreds of mistakes, eventually the missile succeeded in avoiding the one mistake which really would have mattered, missing the target. And to me, this is sort of the essence of agility. It's really resonated with me. The idea is what matters is getting it right in the end, making the correction and having those feedback loops, short feedback loops, and making sure we're understanding any feedback loops that we might be missing that could be critical. So with that, we'll open for questions. This is my contact information. Happy to connect with any of you, LinkedIn, talk with you. Those of you in Houston, happy to connect at any point in time. Let me know.
Hey, Todd, are you there? Can you hear me, Todd?
I hear you.
Okay, so I wanted to first say I really appreciate you being patient with us and working these things out, but that's what it is all about, right? Everybody being distributed. But we did have a question that came in that Matt was asking, what's the role of automation testing or testing results dashboards? How could it play in feedback loops?
Oh, absolutely, right? So that's a quality feedback. That's giving us data that's telling us, are we keeping quality high, or are we introducing some risk, right? And so that's a combination of the results of that feedback. It's also, we have to understand, are we testing enough? Are we having sufficient testing coverage to give us confidence in that? But automation testing is a great one that helps us with shorter cycles on feedback, because approaches where we defer testing till the end. That creates a huge delay. It creates the opportunity for adding problems, injecting defects along the way. It was, as we know, developers write code, and as I write code, they write defects. And so test automation and test-driven development are both approaches that help try to provide us the feedback loop to make sure that we're keeping the quality at a consistent level. So it's a control system. It's a great one.
Awesome. Well, thank you for that. And we had another one that came in that was how the Jenkins pipelines help the teams on the feedback loops.
So I think it's less important on how as important as the result, right? So to the extent that the pipeline, that the overall DevOps pipeline is producing improvement, some of that will be test automation that's providing the feedback internally. Some of that may be the ability to deploy more frequently, in which case you're getting feedback from real customers if you're at the level where you're fully going through the DevOps pipeline all the way to the end. So I think anything that you're doing to help with that, looking at the whole system end to end as a feedback, and then feedback loops will be, some feedback loops will be sort of end to end. There'll be other feedback loops which are very narrow, daily types of feedback, right? Like the whole test-driven development cycle is intended to be very, very short, whereas the DevOps cycle is a bit longer, but still trying to get that as short as possible. So I think you're looking at understanding your system, and as you're understanding your system, what are your types of feedback you're able to get? How do you use the appropriate ones? How do you not get overwhelmed by it as well, right? Sometimes you can react very quickly to data, or have be overwhelmed by it. So you have to be figuring out, how do I get the right level of signal and not too much noise out of all of this that I'm collecting, and balance it appropriately, realizing we've got an incredibly complex system usually. And with that complex system, we're trying to, the important thing is are we on target to get to the end? Not necessarily are we doing everything proper exactly from the get-go.
Right. Thank you for that. We've got a couple minutes left, so I'll give you this one, but just know we have a couple minutes. We want to, make sure that we stayed inside our time box. But how is the Kanban methodology compared to the Scrum framework?
Yeah, so that's a good question. Great question. I look at them as complementary, and we frequently do see them used together. The approach of Kanban is really to be an evolutionary change model. So as an evolutionary change model, we start with what you do now, whatever it might be. If it's Scrum, we start with what you're doing with Scrum. If it's Waterfall, we start with that. If it's Chaos, we'll start there. We don't care. We start with, and we respect what organizations are doing now, organizations and teams, because it won't be the same through the entire organization. We then look at, given what you're doing now, let's analyze it. Let's really make sure we understand how work happens now. Let's document that using the static approach, which is an approach to sort of design the workflows. As then we design the workflows, we look at what could we do incrementally to improve, and how do we design experiments to help us with that. And some of those experiments will succeed, some of those experiments will not. We have to build, that's all part of our feedback loops of trying to understand that. So the way I approach it is that Kanban is a tool that can augment Scrum quite well. You can use it together. What we also find is that teams and organizations may start with Scrum, and they'll find out that they're sort of stalling out. We're calling Scrum stall. They hit a plateau. And frequently what we find then is that Kanban can come in, and we can add Kanban to it and take it to the next level. We can take things to higher performance by incorporating Kanban principles. In some cases, keeping much of the Scrum approach consistent, but perhaps not always doing what some of the Scrum founders would say, is that if you're not using all of Scrum exactly, then you're not doing Scrum. We usually look to try to see, we may break Scrum in some cases, because what we're trying to do is experiment to see what's appropriate in context of what you're doing. And so many teams will evolve some will stay very close to Scrum, some may evolve away from it by implementing Kanban. But Kanban is a change tool. It's how do we keep improving? How do we consistently improve? And how do we improve our measurements? How do we just to get flow? And so there's a lot of tools that we teach in the Kanban approach that I think all can augment someone who's currently doing Scrum.
Awesome. Well, thank you, Todd. And for anybody that had a question that we weren't able to get to, feel free to log into Sketch and add it to the comments section through the thing. We want to thank everybody for attending today's session. And again, Todd, thank you for sharing with us. We value everybody's feedback, so please log in and take the survey just by logging into Sketch, locate the session, today's sessions, click on the feedback survey button. You can get some feedback in that thing, as well as post your questions if we didn't get to one. The recording of the session will be available tomorrow. To get to that, it's kind of the same thing. Just log into Sketch. There's a button that says video stream, and you'll be able to do that. And we hope that everybody enjoys the rest of Virtual Agile Shift. And thank you again, Todd.
Okay, thank you very much. Appreciate it.